Okay, so let's take a look at the questions you had for homework last night. I asked you to do 4 through 8. Number 4 is a box of mass 2.25 kilograms, and it's sitting on a tabletop attached by a horizontal cord over a pulley to one that's 1.3 kilograms. Coefficient of kinetic friction is 0.45. The blocks are released from rest. Find the speed after it has moved 3 centimeters and find the tension. So really, though, the first thing we have to do is we have to find the acceleration. So we have an FG2 acting down here, and we'll have a friction pulling back on number 1. The FG1 and the FN on 1 will just balance each other out, and they're not pulling, so in the direction of motion. So if we were to draw this system in a straight line, FG2 would be pulling this way, and friction on number 1 would be pulling back. And friction, of course, is only acting on number 1 because number 2 isn't on the table. And M2 is going to move down. So when we do the sum of the forces is equal to M total A, FG2 will be positive because that's the direction of motion. Friction is acting against motion. It'll be negative. And that will equal M1 plus M2 times A. We're trying to solve for A, so divide by the M1 plus M2, and it'll be M2G minus friction, and we know friction is mu Fn, so mu, and Fn on number 1 is just going to be M1G because it's on a level surface. So now I can fill my values in. M2 was 1.3 kilograms times 9.81 meters per second squared minus 0.45 times 2.25 kilograms times 9.81 meters per second squared. And that's all going to get divided by 2.25 kilograms and 1.3 kilograms. Now, if you were here, you would tell me what the answer was. So, typing this in, minus and then divided by, you should get 3.55 meters per second squared. With that, we're now able to answer the first part of the question, which is what is the speed? So we're given delta D is 3 centimeters, or 0.03 of a meter. We know VI, we just found A, we want VF. So we would just use VF squared is equal to VI squared plus 2A delta D. The VI goes to 0. VF squared is equal to 2 times that 3.55 meters per second squared times the 0.03 meters. And then don't forget to take the square root. So that 3.55 you just found, you're going to multiply by 0.06. You're going to take the square root and hopefully get 0.21833. 0.21833 meters per second. Part A. Part B wants to know what is the tension. So to find the tension, you can do it on either M1 or M2. I'd probably do it on M2. So acting down will be FG2, acting up will be FT. So it's just like the ones we were doing yesterday. Sum of the forces will equal M2A. It'll be FG2 because that's the positive direction, minus FT equals M2A. Take the FT over, bring the M2A over. So M2G minus M2A equals FT. So FT is going to equal, M2 was the 1.3 kilograms times 9.81 meters per second squared minus the 1.3 kilograms times the 3.55 meters per second squared. FT should equal 1.3, right? 8.138. And is that what I have? No, I have 11. Tension in the cord. Where did I screw up? Did I screw up, or is the answer on my sheet wrong? Because I get 8.138 newtons. Up, down, it'll be negative, we'll go over, it'll be negative, 9.81, 3.55, I got the right speed, but to get 9.81 plus 3.55 times 1.3. I have no idea where I screwed up. So you tell me when you watch this video if I screwed up on the answer sheet or if I screwed up here, because I think this one's right. So I think the answer sheet is wrong. Okay, so let me know what you think. All right, number 5. Number 5 is actually not even a multiple mass. Number 5 is just a single mass, and it's at rest. It doesn't tell us the angle, it doesn't tell us the mass, and at the first part is it wants us to find the angle. So if we do sum of the forces in the x direction is equal to ma, friction, it's going to slide down the incline, or it's going to want to. So it would be, friction would be acting up, so it would be FGX minus friction, and that's going to equal 0 because it's not sliding. And so FGX is mg sine theta equal to friction, which is mu mg cos theta. The mg's will cancel, divide both sides by cos, and you'll have mu is equal to tan theta. So theta will equal the inverse tan of point, and it has to be the static one because it's just about to move. So inverse tan of 0.35 is 19.29. 19.29 degrees. That's part A. Then in part B, it is going to start to move, and so it wants to know what would be the acceleration. It would be good if I did that on the screen. So do the sum of the forces in the x direction. FGX still going down, friction still going back, equal to, this time the MAX doesn't go to 0, so it'll be mg sine theta minus mu mg cos theta will equal MAX. The m's will cancel. You're solving for A. So AX will equal 9.81 meters per second squared times the sine of that 19.29 angle you just found minus friction. This time you have to use the 0.25, 9.81 meters per second squared cos of 19.29. And assuming that my answer is right on the sheet to save a little time, you should end up getting 0.926. 0.926 meters per second squared. How fast is it going when it has traveled 5 meters? So for part C, you just want VF. So VF squared will equal VI squared plus 2A delta D. VI goes to 0. VF squared equals 2 times that 0.926 meters per second squared. And it said 5 meters? Yeah, 5 meters. So multiply that by 10, so 9.32, take the square root. It's going to be something just slightly bigger than 3. 3.04 or thereabouts. So 3.04 meters per second. Done. All right, number 6. Number 6, it shows the 3 blocks arranged in the diagram like I have here. Note that it says A and B weigh, so I'm giving you FG, not M, because they weigh 25 newtons. It tells us the coefficient, and it wants the weight. It wants you to find the weight, FG, of block C. So this is going to be FGBX. This is FGB. And the only thing acting backward on A will be the friction of A. And then, of course, we also have the friction on B. So if we were to draw this in a straight line, pulling this way will be FGC, and pulling back will be 3 forces. FGBX, F of friction on B, and F of friction on